And I'm live. That is pretty cool. Today is 27th of January 2026, Tuesday. And with that, let's start giving the virtual contest. Yep, stop the video here. Codeforces, and the contest is this one. Yesterday I wanted to give this contest virtually, but system testing and hacking was going on, so I couldn't. But today, let's go. Start virtual contest right now, 12:25 at 12:28, let's say, and as individual. Okay, and yep, we are about to start the virtual contest. And before that, new shit, my caps lock key, I have to change that again. Here, keyboard shortcuts for the USB keyboard. Caps lock should act as control. Okay, 2 minutes to go. Yep, cool. Okay, 2 minutes to go. New VM is ready, and we don't need anything else. We can do one little monkey type before the contest, or we cannot do push-ups right now, but we can do this. Okay, that was not bad, very bad. Okay, virtual contest starting in 1 minute. Cool. And this dark theme is also cool. Division 3. And I hope to do at least 4 problems in this. Okay. Yeah. Nothing amazing happening right now. Just a counter going down. I should not have. Uh, I should have decreased the time. Yeah. ITMO supported by ITMO International Moscow. ITMO full form International Transfer Migration Mitigation Transfer Mitigation Outcomes. Okay. It is here. Problem number A. DBMB has a birthday had a birthday party yesterday. Okay, DBMB, that is a name. He was gifted an array A of n elements and a number x. Okay, but there is one problem. He only likes arrays with the sum of the elements equals s. The And to make the array appealing to him, you can perform the following operations any number of times. Choose an index and add x to the number ai. For example, if he was given array this, then choosing an x equals this, you can choose index 3 and index 3 and add 2 to this, and we get this. Okay, your task is to determine whether the array can appeal to bn after any number of operations. Okay, that is not very difficult. Shit. And right, how's the input? First we have n, s, and then a. N, s, and x. int reference x, for int reference x in a c in x, and long sm equals, and simulate a dot begin, a dot not end, and uh, diff e or see out depending on diff, the difference is okay, difference has to be positive, and yes, equals s minus sm. Now if diff is smaller than 0, if diff is smaller than 0, or or diff gives some remainder with x, see out, no, else, see out, yes. Correct answer. Submit code problem A, and just rechecking. That is the whole problem. Sum of this thing. Choose one index, add x to it. Okay. This should probably work. This should better work. Okay, accepted. Cool. Problem number B. How many people have done this? A. 3000. Yes, it was not that difficult. A permutation of length n is an array consisting of n distinct integers from 1 to n in any arbitrary order. Okay, this is a permutation. You are given a permutation p of length n. You can perform the following operation exactly once. Choose two index L and R within the range. Okay, reverse the segment LR in the permutation. Your task is to output lexicographically maximum permutation that can be obtained by performing this operation, and a permutation A is lexicographically greater than a permutation B if for the first okay, lexicographically bigger permutation n and then numbers here. Okay, what do we have to output for each test case? Output the maximum permutation. I think 4123, 4123, yes. Just put the biggest number here, but if the biggest number is already there, then reverse the remainder. Yes, here answer would be 321, 321. Here 4, already the biggest. Yep, already the biggest. Cool. On wait and then C in n, vector integer a size n. Now for reference x a, C in x, and vector in res equals a, and okay, we have to for again int bg equals n for int I equals 0, I is smaller than n, I plus plus. If ai is not equals bg, then break, otherwise bg minus. Right, and okay, bg minus minus, then if bg, if bg is something auto it, we will find in a look for in this range bg which is non-zero And the segment that we are going to flip, is going to be LBG minus, no shit, we want this to be in ascending order. BG is the number, so N minus BG should be the position. If BG is the biggest number, then N 1 2 3. Okay. L is this, and int R is IT minus A dot. Begin. This is the segment that we are going to flip. Is there a built-in function? Equals L I smaller than equal to R I plus plus, right? And we will say res I equals A R smaller than equal to R minus L. A R minus L. C out, and for and I equals 0, I is smaller than I plus plus. C out res I space new line I equal to 10 minus 1. And hopefully this is correct, and this is not. Okay, why would I say here 2 and 2? C out L space R L and R. L and R 1 and 2. So that is correct, but we are not flipping these numbers correctly. We are not flipping 1 and 2. We need to flip 1 and 2. I equals 0. I is smaller than R minus smaller than and equal to. So I would also become equal to R, not I. Yes, shit, that is bad. Not I, but L plus I. Now, cool. And this, we are taking the biggest number that is not in its right place, and we are putting it at its right place. That is the whole thing. Hopefully this also works. Let's see. Hello. I think you gave this contest, Kakashi. Accepted. Cool. Okay, let's go. And now question number 3. How many people have done this? 2000. Shit, 14,000 people have done question number 1 till now. So yes, question number 1 was easy. Easy. And this is the contest. And hello. Problem number C. Today, KQ has an exam at the Grail Academy. A strict teacher gave a task that KQ could not solve. He was given two separate arrays, A, B of length K, of length N. KQ is allowed to perform the following operations on the arrays. Choose an index from A and replace AI with the next number, and okay, and replace a number in A with the same number in B at the same place. Now he has Q queries. Each query is described by two numbers L and R. His task is to find the maximum value of the sum in this range for each query. Maximum value of the sum. maximum value of the sum. If he can perform any number of operations on any elements of the array, since he is not skilled enough for this, he asks for your help. The maximum sum. Okay. Each test consists of several test cases. The first line contains t, okay, then n, and then q number of queries, then integers of a and b, and then q lines follow l and r, okay, n, q, a, b, and l and r. This seems okay. N, q, c, n and q, and then what do we have? We have a and b, vector of integers a like n and b side n, int reference x in a, c in x at a, replace with b, and then and I equal to 0, I smaller than 2i plus plus n, l, and r, taken l and r, and okay, take here the maximum sum for the range 1 to 3 is going to be 9, right? 9, okay, and here 2, 2. Okay, after this we have to update both of the arrays. For and I equals 0, I smaller than n, I plus plus. If bi is greater than ai, then ai equals bi, a very greedy choice, and then we will start going for and I equals n minus 1, I greater than equal to 0, I minus minus from the end, we will start going from the end, and end cbg current maximum is a bracket and a dot back the last element from a, and if a I is greater than no current max equals maximum of current max or ai, and then ai equals current max. I think that is good enough, and then we need like prefix array, int prefix size n plus 1, where prefix I is sum of range a0 to a, sum of range a0 to ai, where this a0 is included but ai is not included. Okay, and for and I equals 0, I smaller than n, I plus plus, we'll say if I equals a, I or pref I plus 1 equals ai plus pref I, right? And after taking l and r, we can just directly output prefix r, that will give a bracket prefix r minus prefix l minus 1. That should work. That should okay, it does not work. Okay, space new line depending if I equals q minus 1. Okay, why do we have 1 here? Does not make sense. It should be q, and now it does work. Okay, cool. Also, this is probably correct. I think probably. I don't know. Let's see. Running on test 1. Okay, this is probably correct. Run 8, test 8, 10. And this times are like actually pretty good. These times. Okay, accepted. Cool. How many people? 1000. Let's go. And question number 4, 16 minutes till now. Okay. You have been gifted a new game called Elite. Elathi. Yeah. You have been gifted a new game. In this game, you are given n swords, each with its own strength. Each sword has its own strength. In particular, the sword numbered I has a strength of AI. The game has chosen n consists of n levels, each of which features a monster. Your task at level 1 and your task you start at level 1 and progress further to pass level I and move to the next level. You need to defeat the monster at level I. To defeat the monster at level I, you need to deal it BI sword strikes. The swords in the games are very fragile, so they can only deal one strike before breaking. If you complete level N or run out of swords, you can finish the game and proceed to score calculation. Before the game, you are allowed to choose the difficulty level. If you choose difficulty X, swords with a strength of X will not affect with a strength less than X will not affect the monsters. The game score in this case is equal to X multiplied by the number of levels completed. Okay, so higher the level, lower number of swords you can use, but higher your score. Your task is to choose the game difficulty in such a way to maximize your score. Seems like binary search, N, and then the array A, and then the array B. The third line contains N, BI integers. BI is the number of uh, blows that are required. Okay, binary search. What will be the minimum score? A and B. A and B are filled. This seems like binary search. There is a highest score that you can get. Highest score would be highest score. Since highest score, we can choose highest score. We don't have to like narrow down to the correct highest score, but the highest score would be the number of n, which is the number of monsters, total monsters, multiplied by the damage of the highest sword. That would be the like best score, and the minimum score would be minimum score that we can get is 0 when we cannot kill any monster. We can always get 0. Let's use long just in case, and long R would be highest score. We don't have to pinpoint to the greatest highest score, but let's just in case long int max is max element on a dot begin and a dot end. What is the problem? Okay, go to that thing and long R would be n into 1 long log into 1 long log into mx plus 1. And so our range for the correct answer would be L, which is always reachable, and R, which is never reachable. So we will have a binary search R minus L greater than 1. 1 long log M is L plus R minus L divided by 2, and we will have a OK function. Okay, should we write out different function or just this is complicated programming, just like do stuff. Okay, int M, or let's just say long log M, and no, we are not binary searching on the score shit, we are binary searching on the difficulty level. Shade, okay, shade. We are binary searching on the difficult. This will require binary search, but binary search like this. If this is our graph, and here we have score, and here we have our difficulty level. At 0 difficulty, we will be able to use all the sorts, but the score is not very. We'll have some sort of curve like this. We have to find the maximum. So I think this is called trinary search or something. Yes, we have to find this place. So how we work here, and we are finding the difficulty which gives us the highest score, so that when we have the difficulty, we can look for that score. No, we are, yes, we are looking for the highest score. We need to find this highest value. So here our minimum difficulty that we can choose is 0, and the maximum difficulty that we can choose is the maximum value of AI max plus 1, let's say. Right, and yep. And what we will do is we will calculate the score for a given difficulty, and also calculate the score towards right of that difficulty, and we will see if this score is higher than this score, it means the correct answer is on the right. So we will go there, somewhere there. But the problem is, maybe, okay, we do know that our score is going to be, or that our final difficulty is going to be one of the values of the sword, one of these values which have been given to us, AI, one of the strengths of the sword. So here we have 1, 4, or 5. So we just have to find our answer on this thing. So what we can do is we can sort this and do our binary search on the values using these as possible scores. That would be nice. Okay, so we have to change a little bit. Change things. Maximum, no. Sort a dot begin, a dot end, smallest to the biggest, and int L 0. But what is our range going to be here? Our range would, So what we have done now is, instead of having a continuous this line for the difficulties which we can choose, we have made a bar graph. We are only looking for certain values of difficulty, because it does not make sense here to choose some other value. Like here, if I were to choose one, or one, choosing one would make sense, because then I would be able to choose this sword, this sword, and this sword. Choosing three makes sense, because then I would be not be able to choose this, but I would be able to choose this. But choosing two does not make sense, because choosing two, I would be able to use these two swords and not these, but my final score would be smaller. And if I were to choose three instead of two, I would still be able to use these two and not this one, but the final score would be greater. So, yep. And shit, I have to use two swords here. So, to kill this monster, and then one sword here to kill this monster. So 2 into 1, answer would be 2, or answer would be 3 if I were to choose 3 into 1. Cool. Our range for answer is L included and R not included, while R minus L is greater than 1. M equals L plus R minus L divided by. Okay, and what are we even looking for here? Okay, shit, 1 second. Cool. Okay, and yes, but the problem is valleys, not valleys, but the problem is at some points we will get this. No, we will not never get the same score, because we are increasing difficulty. So towards the right, we might get a smaller or a higher score. Yes. Okay. Okay. So we will have a function and score which takes in an integer m, let's say, and it also takes in a and b. Reference a, vector, integer, reference b, and long res equals 0, and res equals 0. Return res, how many swords? Difficulty is m. Difficulty is this, and from a we need to find out count. I think count can also take a function. Um, Number of swords we can use is count value, count if. Yes, this is what we want. Count if dot begin and end, and here we have to give in a lambda function int x, return true. Count this if x is greater than or equal to d, and here let's put in d, return res I equals 0, I is smaller than l equals 0 for in x in b. If x is greater than or x amounts of blows are required, and if SW greater than or equal to x, then SW minus equals x. Else break, this will give us the score. Nope, this will not give us the score. Rest would be, we don't even need rest there. We can just here say the number of things killed, the number of things killed multiplied by the score, which is D, the difficulty, not the score. Okay, and using this, okay, if now long score at the current value, score at the current place would be M and A comma B, pass in these, and if M is smaller than N minus 1, then long next score is score M plus 1 comma A comma B, and if next score is greater than SC, you would always, yeah, greater than or even equal to would, no, shit, M is not the score, M is not the score that we are choosing is AM, and here A M plus 1, right? And if the next score is greater, this will never be equal, so we don't even have to consider that. This could be equal, so we also have to consider that. If the next score is greater than or equal to the current score, which means we have to move right. Therefore, L equals M. Else, if the next score is smaller, then R equals M. No, I think this might fail. Long previous A M minus 1 A comma B. If previous is greater than equal to SC, then the current one is not the answer, right? Then the current one is not the answer, then right equals M. This is good. But if the previous one is smaller, then if the previous one is smaller, then we should say L equals M. The current one might be the answer. I don't like this part. Here we are saying if next is smaller than the current score, if the next score is smaller than the current score, then R might be an answer. But that is not true. If the next is smaller, that means next is not the answer, but the current one might be the answer. And here we are saying answer does not include R, but because of this, R might become equal to answer. Therefore, we should maybe do this as M plus 1. But that maybe in some cases might lead to an infinite loop when R and L are not changing. Okay, let's see out score when using L, A, and B. Wrong answer, 0, 0, 0. Yes, best score possible. Uh, Why? Not L. Okay, shit. A, 0. A, L. Okay, still 0. That does not make sense. See out L, R, 1 and 2. Okay, 1, 1. So 3. Right, this should be working. So there is some problem in our this statement. Yes, return true if x is smaller than equal to d. If x is greater than equal to d, right? Kill equals 0 and we are not increasing kill. Okay, that is actually very bad. This might lead to correct scores, but this does not lead. Okay, it is running. Yes. The problem is now, as I said, because of this. Yep, we are getting wrong answers at some point. We also have a possibility that R might be the correct answer. So we'll take the maximum of these two. Maximum of score A, L, comma B, comma A, comma B, and if L is smaller than n minus 1, and then find score of A, L plus 1, comma A, comma B. Otherwise, put 0 here. Okay, wrong answer for this one. Think because of long. Yeah, it's cool. It works for the test cases. We don't know. Otherwise, 2000 people have done this. What are the points of failure? Our sport function is like perfect. Nothing wrong with this. A, B, sort A and B. That is also good. Sort A and B. Good, good. Yes, this might fail at times. Yes, and I do not want to take the risk. So we will do set in, we'll make a set of integers st by giving a dot begin and a dot end, and then we will make a vector of integers scores. We will give st dot begin and st dot end so that all the numbers in x4 are difficult, right? And yep, and then instead of we can just say n would be equal to scores dot size from this point on. So this thing works out. Yep, everything else checks out now. And instead of this, we will say scores. Here also scores. So nothing would ever be equal to each other. So that is a good part. Here we will say instead of A, scores L, and here scores L plus 1 if N is not, if L is not equal to. Okay, cool. This works, does work. Okay, we can submit. Let's see. Problem D, monster game. Okay, okay. Well, this is tense. Wrong answer. Shit. Okay, something messed up, something messed up, something messed up. Somewhere. Scores. Yes, this is long, long. Score is always long, long, so no problem like that. This is also long, long because skill multiplied by long, long 1 multiplied by D, which is also now long, long. And just in case, we can even say just in case. SW, the number of swords which we can use. Right. And AX goes through B. Yep. Previous. There might be a mistake in how we are calculating answer here. Ternary, ternary search, I think it is called. Ternary search. Ternary search, ternary search. I've never like done ternary search. So let's see. We are given a function fx which is unimodal on interval L to R. By unimodal functions, we mean one of two behaviors of the function. The function is strictly increases first, reaches maximum at a single point or over an interval, and then strictly decreases. Okay, yes, yes, this is what this is. No, this might not be what we have. This might not be what we have. There might be cases for which this is not the case. Like maybe our graph is not like this, but like this maybe. And we have to look for the best point. Strictly decreases, reaches a minimum. Okay, let's say here we have a score on this axis and the difficulty on this. Whenever we increase the difficulty, our final score we do know is equal to difficulty multiplied by the number of monsters killed. Let's say that is k, difficulty multiplied by k, number of monsters killed. So whenever we increase the difficulty, our score also increases, directly proportional. But if we also, when we increase the difficulty, the number of monsters that we are going to kill also decreases. So kill is also directly proportional to score, but difficulty is inversely proportional to the number of monsters killed. So can we say that whenever we increase the difficulty, number the score also increases always, because increasing difficulty decreases kill ratio, the number of monsters killed. Yep. But we do know that when difficulty is 0, therefore score would be 0, and when difficulty is like way too much, then we won't be able to kill any monsters. So end point is also 0. We do know the end points in the range 0 to maximum power of a sword plus 1. That is our highest r value, where answer is 0. Okay, and but we what we do not have is this strictly increasing and strictly decreasing. That is something we can say for sure that we do not have, because at some points our function is going to plateau. Yep, our function is going to plateau at some points like this. So yes, like this, our function is going to plateau. How do we find this point? Because if we look at right, these both of these difficulty values give the same score. So where do we go? Do we go towards right or do we go towards left? We don't know. Locally, if we zoom in this point, when we are at a straight line, we do not know whether to go left or to go right, because both of them look same. And so one answer could be that we should maybe increase this range in which we are looking for, and that would mean, how do we decide on the correct range? Because if we were to increase it too much, then we get to the other side, right? Right, we get to the other side and we might look at a score and say, look at this score is smaller than this score, therefore we should go left, because the score on the right is smaller than the score on the left, which means peak is at the left, but actually the peak is on the right here. So ternary search, unimodal function. Our function is not unimodal. Our function is not unimodal. Yep. It uses binary search only. Not even binary search is required. Shit. Okay. Yeah. Eddie doesn't uses that, but technically we are searching. We are searching. It uses while to do that. Binary search in the contest. I first thought about binary search, but later realized that it is doable without it. Okay, I will not read more of the comments that might give me hints. Okay, you didn't use binary search here. And yes, we cannot even do binary or tertiary search. We cannot do tertiary search for binary. Difficulty and score here. We start at level 1. Yes, that is how we calculate score. Multiply x the score, x the difficulty, multiplied by the number of levels completed or monsters killed. We do know which scores we should be using. Those scores are from array A. All the unique values from array A should be the only scores that we should be considering. And for each score, shit, for each of these score, wait, shit, yes, this is doable. This, yes, yes. For each score, let's say SC1, SC2, and everything. For each score, we get how many monsters we can kill with that score. How many swords you will be able to use, some number, right? SW1 swords, SW2 dot dot dot, and for each sword number we can do binary search. No, each sword number tells us how many monsters we will be able to kill. Yes, level 1 plus level 2 plus level 3 swords and plus dot dot dot. Yep. Our score, the sum of the score should be like, yes, whatever this is here. We can have a prefix, and on that prefix we can just use lower bound for this number, and we can get how many levels using this score. Yes, cool. Shit, yes, yes, cool. We can do this without binary search using lower bound. Lower bound will do our binary search thing. For a set, yes. And I think there would be a better way to find out all the unique elements from A, but this is also fine. Right. Vector and kills size would be scores dot size. For each score, we are saying how many monsters we can kill with this score. For size, scores dot size, and I equals 0, I is smaller than sz I plus plus. For int L equals 0, R equals 0, R is smaller than N, L equals R, while R is smaller than N, and A, shit, what are you doing? It's smaller than sz I plus plus. We need to fill kills. Yes, we can directly use lower bound function, but let's use lower bound. Kill for this would be lower bound in A dot begin comma A dot, and look for lower. This does not give us kills. This will give us shit. Yes. Instead of kills, say swords. SW, current sword number. And instead of lower bound, upper bound, comma, for the number scores I minus A dot. This gives us how many sorts we can use with this. So SW I equals CSW. For the ith score, we can use CSW sorts, and this number always keeps decreasing. Right. Response is 0. Now we will go through each score. We also need a prefix. Vector and pref size n. Size would be n. Oh, prefix of yes, vector prefix size n plus 1, yes. And what prefix I means is the number of sort required uh, to reach level I. We have not defeated the monsters at level I, but we have defeated all the monsters till level I plus I minus 1. Now filling the prefix I is smaller than I plus plus I plus 1 equals AI plus prefix I, and now we have a prefix, right? Then we will just go through the sort I is smaller than size I plus plus. We already have rest equals kills would be equal to lower bound. We want how many monsters we can kill. So what is the greatest level that we can reach? Lower bound or upper bound? We will do whatever it is, lower bound or upper bound. We will do it on rift dot begin and rift dot end for the current score I. Why is this function still here? Yes. And minus ref dot begin, lower bound scores begin and end. Look for scores I. For using this ith score, how many people I can kill. That is what the skills variable is. Killed variable is, and is lower bound. We do have to do this lower bound. If the score is 0, then 0. If not scores I, no, not scores I. Swords. This depends on the number of swords we have and scores. Yes. Number of swords that we have. Lower bound. SWI, number of the sum of the number, the sum. Yes, correct. Yes. SWI is the number of swords we can use for the ith score. And this number, that is the number of swords we can use, should be greater than one of the value or even equal to one of the value, or should be strictly greater. this should be strictly greater than one of the values, and in bi is at least 1. Strictly greater equal to or greater, and we do -1. No, pref dot in -1. Yes, cool. Cool. This is good. And then rest equals maximum of killed multiplied by scores I, comma, rest. Mhm. That is wrong, 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 wrong. Fix a parameter and search for the other. Very dangerous thing to do in a contest. Division 3B. Sure, you are talking about some other question. Maybe I messed up with guild. See out scores and the swords we can use. Okay, for the first one, the scores we can use is 1, 3, and 4. The we would be using 1, 3, and 4. Yes, makes sense. And if you go with 1, we will only be able to use one sword. True. If you go with 3, we will only be able to use 2 swords. That is also true. And if you go with 4, we will be able to use 3 swords. Okay, I messed up. If we go with 1, we will be able to use 3 swords. If we go with 3, we will be able to use 2 swords. If we go with 4, we will be able to use 1 sword. Okay, I did mess up. My bad. Begin to end, we have to figure out uh, what are all the values which are greater than this value in A. Okay. Lower bound, greater or equal. Lower bound and A dot end -6. Now I think we should be a bit happy. Yes, 3 to 1. Yes, that is changed, but the answer is still 8, which is wrong. Here answer is 4, that is correct. Then answer is, as we say, 3, which is wrong. Okay, and how can we use 10 swords? Because yes, there are 10 swords, we can use them. 10, and we will be able to kill 10 monsters. But the answer is off by 1 0 somehow. And how can answer be 8 in this case? When we are choosing the score to be 1. Okay, let's see what is the like number of monsters killed multiplied by scores I. Yep, it scores I. The ith is 4. See out killed into score I space compile run. We have only one test case, which is this one. Okay, 2. Yes, which is correct. 2. If we choose the score to be 2, wait, if we choose the score to be 1, 2 is not the right thing. If we choose the score to be 1, we will not be able to kill any monsters. Yep, we will not be able to kill any monsters. So here we should have 0 instead of 2. Which means this variable that we are calculating, killed, this is wrong. One test case, 3, 1, 3, 4, and 2, 1, 1. 2, we are saying that we will be able to kill 2 people, which is completely wrong. So our killed variable is wrong, upper bound, lower bound. Let's output with this. Prefix, compile, run, one test case, 3 values, 1, 3, 4, 2, 1, 1. Okay. 0, 1, 4 is wrong, 8 is wrong. Okay, because I'm stupid. Here instead of substitute A with B. Compile, one test case, 3 values, 1, 3, 4, 2, 1, 1. And 2 swords required, 3 swords required, 4 swords required. That is good. And when 1, we'll get lower bound, upper bound. Yes. We should take lower bound. One test case, 1, 3, 4. Shit, I messed up. We just have one test cases and 3, 1, 3, 4, 2, 1, 1. And answer we say here is 4, which is not true. Answer here is 3. Yes. Killed was equal to 2 for the first case, which is true. We have 3 swords. Yes, true. 1 into 3 is one thing, and then 4. When the score is 4, we can use only one sword. And why is this 1? This should be 0. Because when we have only one sword, we cannot kill anyone. Okay, we have to change our prefix. Oh, yes, we have to change our prefix. Lower bound minus begin. Upper bound minus. Okay, that is wrong. Upper bound minus shade. Just deciding how many levels we are going to destroy. Lower bound and upper bound. lower bound and upper bound, upper bound minus minus. Okay, it was below this. This should be clear. Okay, cool. And this will work always. This will work always. Upper bound minus minus. What we need, what we have is we have our prefix with whose values are always increasing, and we have a number x. These are like discrete values like this, which are always increasing, and we have our number x, and we want to calculate or find out the biggest number that is smaller than or equal to this number. So we just take upper bound and do minus minus, upper bound and minus minus, which would not always, no, this would upper bound minus minus, because upper bound will give us an pointer iterator to to the biggest number that is greater than, strictly greater than our number. And then when we do this iterator minus minus, we move our pointer back and we get a number that is either equal to x or smaller than x, which is what we need. And then from that point, iterator minus minus, we subtract a dot begin, or like prefix dot begin, prefix dot begin, and we get the index of this point I, which is greater than equal to x. Okay. This might work, this might work. Monster game, submit. Let's see how this goes. Don't think so much. Can you tell for each level how many swords you need, and which swords are beneficial? You can find the max among them. Each level, how many? Shit. Each level, how many swords I need? Yes. We can know that. And which swords are beneficial? Which swords are beneficial? Swords which we can use. And find the maximum among that. Here for each score I am, or for each level of difficulty I am finding out what is the score there for that level of difficulty, but this is messed up. Score multiplied by killed. It's not because of time complexity, maybe some integer rounding off error. Yes, integer rounding off error. Shit. This is fine. This is just index. Yes, index. So this is fine. Size. This is also fine as this is score. Shit, maybe this was the error. Prefix. Everything else seems fine. Here we are taking in the input, the complete whole input. Here we are taking on all the unique values in A, and then we, yes, all the unique values in A, Z, sorting A, and then we are finding out for each score in scores vector how many monsters we can kill with that, or how many swords we can use for that. And then here we are calculating with that score how many monsters we can kill, and then we are multiplying the kill with the score to get the shit. Okay, I messed up with the score and difficulty. This should not be scores, this should be difficulty. I messed up in the naming. Scores instead of scores, say diff So number of things killed multiplied by difficulty for each difficulty level. This probably was a out of bounds error. Not out of bounds, but this long. We are adding things in the prefix, so shit. What are the standings? Okay, shit. Yes, that was the error. That was the error, and somehow this is now white. Shit, my standing is not good. My standing is not. Shit, my standing is literally not good. Where am I? Here. 8,000 people and have done this. Shit, that is crazy. 7,000. Okay, that is bad. That is very bad. Cool. Accepted. We can move on to the next problem. That increased my standing a little bit. That did a little bit only. Okay, shit. Today, subson was called to the board with an array A of length n and was assigned an officer's task array A of length n to answer n questions. In the ith question, it is required to determine the minimum number of elements from the array that need to be selected from the board. It is allowed to use the same elements multiple times so that their product is exactly equal to I, or report that it is impossible to achieve such a product. Note that at least one element must be selected. Okay. Yes, minus 1, 2, 1, 1, and then A. Okay, this is, yes, one indexed. This is one indexed. Okay, one cannot be achieved, two can be achieved, three can be achieved, four can be achieved. Two into two is four. This one is okay. Then five cannot be achieved. So okay, and we have to give minimum number of elements required to obtain that sum. Okay, 5 is not achievable, so minus 1. And then 6 is achievable, 2 into, or directly we can use 6. Then 7, directly we can have 7. And 8, for 8 we cannot have 8. We can have 8. How can we have 8? We just have two twos. How can we have 8? They're saying we can use 3 numbers, but what are the 3 numbers? 2 into multiple. Okay, we can use each number multiple number of times. Okay, shit. Yes, it is allowed to use the same element multiple times. So we can use 2 into 2 into 2 and we get 8. Okay, this works. Maybe we need some pre-processing in this. For each number, greatest value of n is this. For each number, we need to find out factors. Its factors. Yes. And multiply some subset of these numbers so that we get the final number. Here 1, 1 and minus 1, minus 1. We have 1, we have 2, we have 3 directly, we have 4. 2 into 2, 4. And 5, yes. All the numbers are here. Minus 3 into 3. We need all the factors. Shit. Don't help him. Yes. Reality is cruel. Yeah. We need to find out factors for each number. For each number. Let's say we have an array which we can use whatever our number is, like AI, whatever our index is, AI, which we want to like fractionate it. We can call the function recursively, but we cannot go manually for each of these numbers. Mm. We can calculate the factors. We can have the factors. Let's say for a number I, we can go through its factors. And how much time? 3 seconds. Okay, that is good. I, for I, we can go through its factors and call the function on itself recursively. Yeah. Okay, if we have, for example, 8, then we will have a array, or we will have a matrix, a 2D array, in which, let's say, it is called fact, and at 8, since this is 2D, we will have a list which will say 1, 2, 4, and 8. These are all the factors of 8 we can use. Right, so we will try to make different. We will not have 1 and we will not have 8. So shit. We will see, do we have, first of all, for any function called, we will see, do we have this number directly in our array? If we do, then this function will return 1. But if we do not, then we will look at facts, and in here we will look at, okay, one pair of factors we can make is using 2 and 4. So we will call the function again for 2 and function for 4. 2 into 4 is 8. Then for 2 we will see that 2 directly is in the list, so this will return 1, and this we will see that 4 is not in the list, so this will again look at factors of 4, which are 2 and 2. This will call the function for 2 and 2, and we will also use memoization. So this will return 1, this will also return 1, and we will get 1 plus 1 plus 1, 3 as the answer for 8. And we will use memoization. We will use memoization. Yes, we will use memoization, so that we are happy. And facts. In this facts, we can calculate, do some pre-calculation to find this, the same way that we use, that we can use a thing similar to sieve of Eratosthenes. Yes. Yep, we can use the same thing, something similar to that. Yep. But yes, we will have all the factors for 9 in the factors thing. Will we have 2 3s or a single 3? Let's have a single 3. Single 3 makes sense. Okay, some pre-calculation. This is not very satisfying. Shit, I messed up with the fourth one. This took me more than 1 hour, and yeah, one, two wrong submissions. Vector of vector fact, how many range is, as we see here, 3 into 10 power 5. Let's use 3e5 plus 4e5 just in case. And here range vector int empty and void fill for int I equals to I is smaller than equal to range I plus plus should not be equal to the range, smaller than range. Right, we are looking for all the numbers that I is a factor of. So for now int c equals 1 while, and also let's change this. Yes, and this is fine. While c into 1 long into I smaller than range c plus plus c plus plus, yes, factors, we will say c into I dot push back that I is a factor of c into I, right? And then here fill, okay, cn vector int def a size n or n reference x a taken s taken not sx taken x, and now cool, okay, a map int to int memo I equals to I smaller than n smaller than equal to n I plus plus. Yes, we need to call the function. What is the function? Yes, that is a nice point. Int function is called function, and in this function this takes in a number int, let's say I, and r. Yes, this takes in I, and this, instead of this, let's use multiset of integers a int c for int I equals 0 I smaller than n I plus plus c in c and a dot insert c. Why a multiset? Because this helps us in looking up if the element directly exists in our array or not. We don't even need a multiset, we just need a set, because we can use the same number again and again, does not matter. Set of integers reference a. Now if a dot count I, if we have I directly, then if we have I directly, then return 1. Otherwise, we have to go through factors of I. For int x in fact I. And here we will not begin with 1. We will not begin with 1. We will begin with 2. Res equals 0. So 1. Res equals minimum of, so we should not use this as int max minimum of res, or call the function like this with x and I divided by x, and x comma a plus function for I divided by x comma a. And here if memo dot count a I, then return memo I, and here memo I equals res, and then return res, and yes, the answer is fun. This is wrong. This is wrong. Minimum of res function a plus function I divided by x. What if the number does not exist? Okay, when I is 1, for example, this will be false. We will not go through this loop because I does not exist. Right, and if this was 7, 7 would not also have would not have factors. 8, 5, 8 would have factors, but we will go through this and we will see that they don't exist. So what will be returned? -1. They will return -1. Okay, here int max is good. Okay, this is good. Here cout, call the function for I and given a, if this thing equals int max, then say -1, otherwise shit. Res is call the function for I and given a, and now cout if res equals int max question mark, then -1, otherwise res. Okay, space I equals n line and I equals n. Okay, this is good. And here we are saying -1. Why are we saying -1 in this one, even though we do have 1 here? And here what do we say? 2. 2 does not make sense. A, we are inserting into A. Shit. Memo, we also have to update memo every time. Yes, but we do not have to update anything else. We just have to update memo. Memo we can pass directly also, or we can yeah, we can just empty the memo every time. Or yeah, clear. And now probably correct. Good. Time complexity, what would be the time complexity of this? And right, all of this is linear, and then this is linear. We are going time complexity for this loop is n, and for each of those n we are doing a function calls. And how much time does it take for one function call to process? We are going through factors of that number, and I think going through the factors for a number takes for a number n, it takes up about log n time, and we are doing this for n different numbers. N log n would be the time complexity, hopefully, and even if it is not, 3 seconds is long enough time. And also time complexity for sieve of Eratosthenes, something and log n. The code, let's see. Hello. Sir, okay. Hello, not funny here. Came here and I'm new to DSA. Hello, you can do DSA. We're gonna start doing DSA question. Problem number E, and this is pretty fun. And right now, okay, screen is stuck. My bad. Wait, restart. Okay, shit. Okay, it was stuck. My bad. You were not able to see anything. Okay, what is happening is yes, EKJD. I don't get that. You are new to DSA. Shit. Okay, in DSA, what happens is you get problems and then you give wrong answers to those problems and you get sad. Okay, this does not work. This does not work for test number 2. So probably there is some mistake in the logic and we are not getting time complexity error. We are getting literal like wrong answer error. This should work. This should be working. We are getting wrong answer error. Okay. Shit. Wrong answer. Wrong answer. We're taking in n and a set. We are also clearing memo and rest equals 0 and for each value I, function call I and a. This is our set. For this set, find the value for this I with whose product we want to reach. And we already know the answer, if we already know the answer, then return the answer. Otherwise, if we do not know the answer, then check if this number exists directly. If this number exists directly, then okay, then we are okay. Shit. Okay, yes. Here is the problem. Yes, here is the problem. Here is the problem. Before this should be long, long, out of bounds. That is the problem here. And rest is long, long. This will also be a long, long, so that when we are multiplying or adding two int max values here, we do not mess up our answer. Yep, we do not mess up our answers. Okay, and let's also write an example where this fails. Compile, let's say we just have one test case and it has four elements. Let's say one of the numbers is let's say is 12. No, shit, 12 would not work. Okay, I will not get into where this will fail, but yeah, this will fail, this will fail. Long, long. So we can move by paragraph in Vim. Yes. It's long, long. And hopefully this works. Just in case, wait. You can see, yes, mine and int max. Rest, yes. Let's make this one also long, long, even though there was no need. Only 30 minutes remaining for the contest. E. Okay. Okay, yes, that was the problem. That was. Let's see. Okay, yo, maybe I might be able to solve faster than this person here. Yes, cool. Okay, my rank is now fourth. No, 4,000 is still bad in Division 3. 4,000 is still bad. Let's move on to 2 to 3,000 is very good. Till 3,000 is very good. But yeah, yeah, most of the people here okay, are like mm, cheating. Quite a few people. Okay, I don't want to say as to the proportion, but yes, quite a few people would be cheating, and this seems like I'm crying. No, right. Uh, okay. One more, one more. In division 2 and 1, people like don't really cheat, but in division 4 and 3, quite a few people do cheat, and that is not very good. It affects the ratings. But yeah, these problems here have been easier. Okay, courier YF has entered the title, earned the title of best pizza delivery person, GR, general relativity. The manager does not like him, so he decided to give him a very difficult task. The manager provided him with n coordinates of houses like this where he needs to deliver the pizza. He will deliver. Shit, is this like traveling salesman problem? And also screen is not stuck. That is cool. GR pizza is prepared at the point this, and YF, why are their names like this? And YF starts the delivery from this point. To deliver the pizza, he can move from point this to this, uh, from the current point to three different points. Okay, he cannot go back in the X direction. Okay, after he has delivered all the pizzas, he returns back home to this. How can he return back home? To the point BX and BY. Okay, home, and bx should be greater than ay because he cannot go back in x direction. Each move takes him exactly 1 second and handing over the pizza to the customer takes 0 seconds. The manager wants the delivery to be as fast as possible. You need to find the minimum delivery time for all GR pizzas. It is guaranteed that delivery is always possible. Okay, we have an AY BY, right? And then n is the number of coordinates, and each line contains, then the next line, second line contains all the x, and the third line contains all the y's. Shade. Okay, yes, this is good. This is good. For example, we are here in x direction. In x, we will always move towards right. Right, we will always move towards right in x direction. So yeah, we will have this central line on which we will keep moving towards right. And I was thinking maybe if we have one pizza place here, place here, place here, so we'll just go there and come back, go there, come back, move forward to the next x location, go there, come back, go there, come back. But maybe we might have something like this, where if we go to this place, then instead of coming back, going forward and then going there, we could from this place only go right and go up, which is cool, right? So we will go forward by y coordinates. We'll go forward by y coordinates. We cannot go forward, we can go forward by y coordinates. Okay, we'll go forward by y coordinates. We will start from wherever the place is, then we will go to the next y coordinate wherever it is, and we will at that y, at that x, we will move x by x. Yes, x by x, x coordinates, x 3 2 1, not y but x. At this x you will see how many different pizza places there are, how many different places there are that we have to go to, and we will find the one for this x that is closest to our current point. We will move forward to that place. Yes, we will move forward to that place, and yes, then we have to deliver pizza to all the places. We have to deliver pizza to all the places. Let's say we are at some x value, at some like some x value, x this, and we are at some pizza point. Then the only possible places that we can end up at the end would be either this or this. Now we have two, when we are at a place we have two options, either move in this direction or move in this direction. If we go forward in this direction, then to deliver pizzas to these places we have to go back, and this would be the last one that we are at, so we will end up at this. But if we were to initially move in this direction, then we will deliver pizza to this, and passing through this, then we will have to go back to deliver pizza to this place, and we will end up at this. But what if this point is one of the end points? If this point is one of the end points, if we start from one of the end points, let's say this, then we will certainly end up at the other end point. Okay, and we will move like this, and then for each end point that we end up at, you will find the one that is in the next layer that is closest, and we will go directly to that point. We will go directly to that point. Yep. And if we were to go there to some other point that is not closest, we will go there and we will end up here. Okay, so for each endpoint we can decide which one we are going to end up at. No matter where I am here, I will be at one of the endpoints, which is the best thing to be at. Yes, we can decide which point to end up at. We can decide which point to end up at. Let's look at this. We start from 1 to 1 2. This is our starting point, and next let's sort this. The next closest x is 2, so from 1 to 2, and for that 2 we have 5 here. 5, this is the next pizza place. Then the next x is 3, and for that we have two y values, 1 and so next x is 3, and we have 1 and so 1 pizza point is here, and 3 1 point is here. And then for 4 we do not have a x, then we have x at 5 here, and for 5 we have at 1 4 and 6 1 at 4 and at 6, and then we have to end up at 7 3 7. This is 5 6 7. We have to end up at 7 3, this point. Okay, what should be the best path? Let's look at this. So from here we must go there, so 1 unit distance, and then 3 units, 1 2 3 3 units, 4 to get from this layer to this layer, and then here from here we'll we can either end up going there or end up going there. I think it does not even matter if we go to this point first, let's say, then we move 2 distance here and 1 distance here, and we end up and we go here, and then we move 2 distance down and we end up here. From here we can go directly there, or let's say yes, we will go directly here, and from here we'll go up and up, we will end up here, and from there we'll go down and right, we will end up here. Right, and another path would be, let's say we went down 2 distance, went down 2 distance, went forward 1 distance, and went up this distance, and we ended up here. Okay, this is certainly not very efficient because we are going back. Yep, this distance is extra, this distance here is extra and could have been avoided, but yes, this distance is extra. So it is always good to start at one of the to start at a end point that is closest to us. That makes sense, that makes sense. So for this one, the closest one is this, and we end up at this. From this, closest is this, we go there, we go to the other side. From here, the closest is this, and we go here. Okay, so what would be the actual answer? Let's see. We move forward here by 1 distance, and we have to move up by 3 more distance, 1 2 3. So we reach this point by traveling 4 units. Then closest endpoint is this. So here 1, 2 and 1, 3. So we reach this point by total distance of 7, and then we move down to twice 9. Then closest is this 11, 2 more distance, and this one is 1, 2, 3 points above, so 14. And the other one, this one is 2 points above, 16. And from here you have to move forward 2 distance, 18, and then 2 distance down, or 3 distance down, 21. Is 21 the answer? Nope, answer is 19. Answer is 19. Answer is 19. 21 is not the answer. Shit. Answer is 19. 21 is not the answer. 16 minutes for this problem. 4000 is still not a very good rank. We are messed up in distance calculation. We start from here, go forward 1. Okay, we will not count the, let's say, x distance. In y, we go from here to here, 3, up and down. Up and down, shit. If you are at some point in the next layer, we have all of these points. Let's say we start here. We have multiple options that we can go to in the next layer. If we go here, we cover this extra distance to go to get to that point, and we cover this extra to cover all the rest of the points. If we go here to this point, then we cover this extra distance to get to this point, and we can now end up here or here. If you want to end up here, then we go down, cover this much distance, and we cover this much to go up. So what is the difference between these two? Pink one is better somehow. Pink one is better because the only region that we are covering twice is this much, this region, and in white we are covering this much distance twice, so it is not good. And if we go here, and also in pink one, we could go above first, then go down, and then go down. We will end up here. Okay, yes. But if we want to end up here, we can do it faster here. Here, yes. And okay, if we go here, and if we want to end up here, we first of all we covered this much distance for blue, and then to go up we will cover this much. And from shit, I messed up in pink. In pink, we, if you want to end up here, we go up, we go down, and then we go this much down. So shade, yes. In pink, extra distance covered is same as in the white one, which is this much. Okay, and if we wanted to end up at this point, then in pink we would first go down, then go up, and then go up this much, which says yes. Go up, down, and down, right? But if you were to go down, 1, 2, 3, and if you were to go down first, down, then up, and then up, one of these is doubling. We do not want to double. We want to double the distance that is smaller, right? So if we do end up at one of the end points, we will double the one that is 0. Okay, so let's say we will always go to one of the endpoints. Going to the endpoints is cool. End n x y, and these are the starting points, and end x, end y, these are the end points. Taken n, x, y, ex, ey, and then all the points. Vector end x size is n and y size is also n, or int reference x and x. Okay, that is not a very good name with me. A n c in x, c in a, and replace with y, fill in y, right? Okay. Response initially is 0, and no shit. We should make a vector a size n of pairs of integer for auto reference x comma y in a, c in x, and y response initially is 0. Initially response is 0, and shit, 9 minutes remaining for the contest. Response is 0. We need to keep track of our current x. Before that, we will sort this whole thing, a dot begin and a dot end based on the x values, which is correct. So in cx, current x is equal to capital X, the place that we begin at, right? And also in cy is equal to capital Y. Okay, and for for auto x comma y in x comma y, after sorting, it would be cool if we had a vector, if we have a two-dimensional vector of pairs. Vector in t size we don't know yet. Vector of vector of integers. Visualize this, yes. Yes, okay. And then here, not auto, for int I equals 0, I is smaller than n, I plus plus, no, for int L equals 0, R equals 0, R is smaller than n, L equals R, while R is smaller than n, and L and R and A bracket L dot second first equals A R dot equal R plus plus and A, yes, not just this, T dot push back empty vector of pair of integers. Yep. Do R plus plus, but we also know that whatever is at this R position, we can add it to our T. So T dot back dot push back to this vector A bracket R. Yes. Pull A bracket R. Okay. And now we'll go X coordinate by X coordinate. So for auto targets reference, let's say for auto reference targets in T. First of all, we have to get to T, therefore we have to get to this X coordinate, therefore res plus equals the target X, which is tar, any element from tar 0 dot not plus equal to this, like this minus the X, which also we don't have to do because at the end res plus equals, at the end we can say res plus equals the final X, which is ending X minus the starting X. So current X doesn't actually matter, so we have to keep track of it. See out res line. Okay. Okay, and yeah, 3 minutes we probably won't be able to do this, but let's see, maybe we can do this. 3K people solved it. Wait, 3,000 people solved this one or the one before this. Bro, what is your peak rank? 14. And how much time have you started doing it consistently? Like started doing this consistently, but then it stopped for a few months, and now I have started doing this again. Yep, and peak was 14. You can like look at the stats. 1420. here. But this feels like self-promotion. This is my username, and I will not send the link because that just seems like, yeah, too much hubris. If you want to check it out, you can check out from here. Hmm. Yes, around 3,000 people have solved this one. Free pizza. The concept is straightforward. We are at some points. We Let's say we are here. We cover this and go down. Wait, shit. Ah, wait, shit. 1 minute. I was getting call. Now, fine. Yep, cool. Okay, we go up, we go down, we go down. We end up there, right? And then we get a new set of points. Let's say all over the place. And right now the question is which place to start at. Yes, it depends on the highest and the lowest. What is the least distance that I want to cover twice? Here. Yes, let's use this. Tar and this tar vector, this is also sorted because of this sort function, and this is sorting this whole pair, and if two x values are equal to each other, then they are sorting this according to their y value. So tar is also sorted. Cool. Right, tar, and currently we are at cy, right? Then we will end up at one of the endpoints. Currently we are at cy, let's say. We'll end up here or we will end up here. Those are the only two things which matter. How many points are in between, that literally does not matter. Either we go there first and then we go there, right? Let's say this is y max, this is y min, and this is y max, right? Or let's call these, this is y dash single dash and y dash dash. So either our final thing that we add to our answer is we go down first, then we go up, and then we go up. Final thing that we add would be 2y dash plus y dash dash, or y dash plus 2y dash dash. And also cy changes to y double dash if we use this formula, and it changes to y single dash if we use this formula. Let's always use greedily the one that is better here. Okay, and yep, int y maximum is tar dot back dot second, and int y minimum is tar dot back dot tar the first element dot second, and it could also be the case that tar only has a single number. Yep, okay. We will say if there are two formulas below and above. Below, if we go below, wait, no, this is above and this is below. Above, if y value is higher, then it is above, right? And if we go above, or it might also be the case that our point is here and the above value and the below value both are in the same direction, in which case we would certainly go here and then we will go here, which is the best thing to do. Yep. Ymn and yn. Okay. First, we will check for this thing if both the points are smaller. So if ymx is smaller, if ymx is smaller than or equal to parent y, whatever the result of this thing is the same as ymn smaller than equal to parent y. If that is the case, then we add to our answer, or yes, to our answer, current y would be response plus equals maximum of absolute difference of cy minus ymx, comma absolute difference of cy minus ymn. Yep, we are getting absolute difference of this and absolute difference of this, and we are adding the maximum one, which is cool. And we want now cy to change to the value that is further away from this, from cy. So if absolute value cy minus ymx is greater than absolute value, or if both the points are at the right place, then yes. If both the points are at a similar distance, then how do we decide which place to go to, which place to end up at? It would be decided based on where the points are in the next phase. Okay, if the points are like this and we decided to end up here, which means we go here first, we go down, then we go up here and here, and okay, I guess the contest has ended. Yes, the contest has ended. No, 5,000 in division 3 is not a very good rank. Yeah, I will think about this later on. I can add this problem to list, review later on. Yep, save. And yep, okay, what I'm unable to decide here or figure out here is that does it even matter which point we end up at, which point we end up at? Yes, I mean it does matter, because if we have like 2 points in a layer and in the next layer all the points are here, and if we end up at this point, it would be like closer to get to these points than compared to this. But there would also be a cost to end up at this point and a separate cost to end up at this point, and I think that the costs would like clear out, would balance out and at the end it would not matter which point we end up at, I think. And yep, that would also be, we did 5 questions, which is fine, but still I guess we could have done this one also. Okay, and that would also be the end of today's stream, and thank you for being here. Bye.